Hello and welcome to the section of Calculus Extra Practice with Integration. Here we're going to continue working with integration by parts, and at the very end of the last section I asked you, what do you think the form of the integral needs to look like in order to require doing integration by parts 3 times? And I'm going to show you the answer right now. So what we have is the integral of x cubed times cosine of x dx. This integral is going to require integration parts, not 1 time, not 2 times, but 3 times. And after the discussion at the end of the last section, I hope you can kind of understand why. We have x cubed, which is destructible, but we'll need to take its derivative basically 3 times to kill it, so to speak. And this guy's indestructible. So what we're going to do is do integration by parts once, and then the integral that we get at the end is going to be simpler, but we'll still need integration by parts to tackle it, and it should involve an x squared. Then when we do it again, the integral that we get the second time around should be simpler still, but it's still going to involve an x. And then finally we'll do it a third time, and then we'll get down to the point. So each time we do integration by parts, we keep taking derivatives of what's over here because we keep choosing u for this term here. So it keeps getting simpler and simpler each time, and that's why integration by parts is so useful for functions that have a destructible times an indestructible. And that's kind of why I kind of keep harping about it so that you can understand the reasoning. So let's just dive into it. It does require you to show every step and be very careful because doing integration by parts 3 times is just a recipe to get something wrong. So u is equal to x cubed, and dv is the integral, actually, let's not do it that way. dv is cosine of x dx. All right, so let's just do this. What we're going to have is du is 3x squared dx. If this bothers you that I write it this way, just think du with respect to x is 3x squared, and then I just move the dx over to the other side. And then v is the integral of cosine of x dx, which we know. The integral of cosine is just sine of x. So I've got everything in place. I've got u, I've got du, I've got v, and I've got dv. So I can move along and go ahead and try to put this into uv minus integral of v du. U is x cubed, v is sine of x. So u times v minus the integral of v, which is sine of x, du, which is sine of x, times du, which is 3x squared dx. So I think you can kind of see where this is going. What we have here is x cubed times the sine of x minus, the 3 could come out, but the integral is still going to be x squared times the sine of x dx. So you should ask yourself, as you always do, is this integral simpler than the one I started with? And it is. I mean, even though the cosine changed into a sine, and that's not really, that's not really any simpler, so to speak, the x cubed turned into an x squared, and the reason is exactly what we've been talking about, because every time you do integration by parts and you choose this to be u, you take its derivative and so it gets simpler. If you keep doing the process over and over, eventually it's going to die. Okay, so now what we need to do is focus our attention on this integral. Notice that we have this as part of our final answer, minus 3 times the answer to this integral, so don't forget that your 3 is out in front here. But we need to focus on this. So I think we have enough room to do this integration by parts. We'll set u is equal to x squared. We'll set dv is equal to sine of x dx. And so what we'll have is du